Hello, my dear students. Positive integers, that numbers, if you take except 1, the remaining numbers we can classify as two categories of numbers. One is prime numbers, another one is composite number. What is a prime number? If you factorize a number, then it has only two factors. One, that two factors are 1 and itself. Such kind of numbers we are saying it as a prime number. For example, if you factorize 23, we won't get any other factor other than 1 and 23. So it has only two factors. So that 23 is a prime number. We can give many other numbers, such numbers 7, 11, 17, 19, 29, such numbers we can say. Let us see another type of number, composite. Composite number means which has factors more than 2. So we can see that, for example, 12. If you take 12 has factors, we can write 1 into 12, 2 into 6, 3 into 4. So 12 has factors are, the factors of 12 are 2, 1, 2, 3, 4 and 12. If you see, 12 has 1, 2, 3, 4, 5. 5 factors, more than 2 factors. So 12 is a composite number. So if a number has only 2 factors, 1 and itself, it is called as prime number. A number has more than 2 factors, it is called as composite. Every positive integers, we can say it is either a prime number or we can write as a product of prime numbers. What is the product of prime numbers? We can take one composite number, our previous example 12, that same number we can take it and we can analyze whether we can write it as a product of prime number. What does it mean? If you take 12, we know that 12 we can write as any numbers, for example, other than 1 and 12, we can take any other factors like 2 and 6. Here 2 is prime number and 6 is a composite number, and 6 further we can factorize as 2 and 3. So 2 and 3 are, if you see, 2 is prime number and 3 is also a prime number. So 12 we can write as 2 into 2 into 3. This kind of expression we are calling it as product of prime numbers. So that we can say that every composite number we can write as a product of prime numbers like this. So in this product of prime factorization, we can write the order in which the numbers occur, we can change it. Like we can write or 3 into 2 into 2 or 2 into 3 into 2. Any order we can change it. The order in which they are occurring, they are coming is not at all problem. We can write in any way, but the numbers appearing are unique, which means we can't write 12 only with using any other prime factors or any other numbers. we can only use it is a unique expression. We can use 2 2s and 1 3 to write it. We cannot use. You can try. I'm giving you a challenge. You can try. You can take any composite number and find out can you write any other way of writing. So here we can't write. It is a unique. Unique means, for example, you are watching Rob. Who is watching me are a unique person. There is no other person like you in this world, right? That is, we say it is unique. So for 12, there is no other way of writing other than this. We can change the number. This is what the fundamental theorem of arithmetic says. The topic we are learning that. So the theorem is every composite number can be expressed as a product of prime numbers, and this prime factorization is unique except for the order in which the prime factors occur. That is it says that. So what it says, we can write any composite number as a product of prime numbers. This prime factorization is unique, but we can change the order. We can write any order, the numbers, order of the numbers we can change. That doesn't matter, but it is unique. You can't write in any other way. Now let us do some problems based on fundamental theorem of arithmetic. We can see the application of it. Application means where we are using it. The first application we are using in number theory or representing numbers. In that we are going to use it. And the second application is we are going to find out the LCM, HCF of 2 or 3 numbers or many numbers we can find out. That is third one. And later in this exercise, we are going to do. We are going to apply this concept of finding LCM and HCF in real life problems and day-to-day problems. These are the things we are doing in it. Now let us see one problem based on fundamental theorem of arithmetic. The question is express 7429 as a product of primes. Primes means prime number in short. So we are going to write a factor tree here. Factor tree you learned in smaller classes. So this chapter is not that much tough. It is not hard one. What are the things you are learning or you learned already in the lower classes that you are summing up under the one heading real numbers. Here this number, what is it? 7429. Now we have to find out the prime factors. So this number we have to divide by prime numbers. Okay, because we have product of primes, we have to divide by prime numbers. What are the prime numbers? We know that we can write now. So the prime numbers, first prime number 2, second is 3, third prime number 5, fourth prime number, next prime number 7, then 11, then 13, then 14, 15, 16 is not prime number, 17, then 18, 19 not 18, after 18, 19 is prime number, then 20, 21 is not a prime number, 22 is not a prime number, 23, then 24 is not a prime number, 25, 26 not a prime number, then 27 is also not a prime number, then after that 29. So we are writing just up to prime numbers between 1 to 30. Okay, so using these numbers we are going to divide this one. Before going to divide, we are direct divide. We are not going to do that. We are going to check each numbers one by one. Okay, this time we should remember the divisibility rule. We studied class divisibility rule. So first we have to check the divisibility rule. That check the rule satisfy angle divide. Otherwise, first we should check it. If the rule is satisfied, we can go for it. Otherwise, don't divide. Don't waste your time. This is all the shortcut methods. These are the divisibility rule tells us to do it very simply. It is teaching us. So if it is a number should be divisible by 2, the last number the ones digit should be even number. So it is not an even number, so it is not divisible by 2. So no, we can't divide by 2. The next number. What is the divisibility rule of 3? If you are adding all numbers, the sum of the digits should be a multiple of 3. 3 or multiple of 3. For example, we are adding 7 plus 4 plus 2 plus 9. When you add everything, what we get? So 7 plus 4, 11, and 2 plus 9 is 11. So 11 plus 11, 22 is not a multiple of 3. So it is not divisible by 3. So we can go for next prime number 5. If you select 5, if a number ends with 0 or 5, that number is divisible by 5. So here this number ends with 9. So it is not divisible by 5. And divisibility 7, we can go for a long division method and check whether it is completely divisible. So we can go for 7, 4, 2, 9, divisible by, we can check by 7. So goes 7 one time and 0, we can take it down 4, it is not divisible, so we put 0 here and we take the next number 2. 6 7s are 42, then we take it down, this is 0, we take it down 9, 1 time 7. So we are getting remainder as 2. It is not divisible by 7. So we can, 7 is not possible. Then we can go for a divisibility. We can check for 11. There is a shortcut method, easy method for 11 also. So what is it? If you are adding that alternative numbers, it should be equal. So if you are adding 7 plus 2 is 9, and you are adding these two numbers 13. So 9 and 13, they are not equal. So this number is not divisible by 11. 11 or we can next number choose. Now let us try with 13, and 13 we are going to divide the first number 74. We can have a guess of we can do trial and error method. The easy way to check it is multiplying this number by 5 and check it. That is the easy way to do it. So we can find out whether it is greater than 5 times or less than 5 times. So 13 into 5, 3 5s are 15, remainder 1, 1 5 is 5 plus 1, 65 we are getting. So lesser than that. If you go for one more time, what happens? Plus 13, we can go for it. So 8, 78. So if it is 6 times is greater, so we can select 5 times. So 5 times remainder is 6. So it is not divisible. Now let us try with the next number 17. So 7429, we can try to divide by 17. As we did, that is the easy way to select. We can multiply by 5. So 7 5s are 35, remainder 3. So when you mount 5 is 5 plus 1, 85. It goes 85 times. So it is enough to go. Okay. So 14 times we can multiply. So 4 7s are 28. The remainder is 2. 1 4 is 4 plus 2, 68. So when you subtract, we get the remainder as 6. Put down 2. So 62. So 4 times 17 is 68 we got, isn't it? So here 62 only. So it won't be 4 times, isn't it? So we can go for 3 times 17. So 3 times 17, just we multiply. 7 3s are 21, remainder 2. So 1 3 is 3 plus 2 5 51. Then you subtract this one. So we get 11. The 9 put down. Okay. This, if you see, this number ends with 9, isn't it? So here we are going to multiply by 17. So do you know that 7 into 7, 79, it also ends with 9, isn't it? So we can go for 7 here. So 7 sevens are 49, 4 is remainder, and 1 7 is 7 plus 4, 11. So completely divides. So one of the factor is 17. So just we saw that if you divide by 17, we get the quotient as 437. So now we have to divide the 437, and we have to try with another factor. So we can divide next number is 19. We can try with 437 dividing by 19. So we can take 20 as a round off. Either 20 so adana korchum kudi easy. So here 43, that is we can round off to 40. 40 ആക്കി എടുക്കാണ് കുറച്ചും കൂടി easy ആവും, because 20 into 2 is 40. Easy ആയിട്ട് നമുക്ക് എഴുതാൻ പറ്റും. So 2 times 19 ആവണം. So 2 times 19 means it is 38. So when we subtract, we get 5. Then we can put this 7 there. This is how we can round off to 60. So 3 times 20 is 60. 3 times 20 is 60. So we can select 3 times. 3 times 19 anengil 57 we get. So remainder is 0. So we can, if you divide by 90, so we get that quotient as 23. Okay. So we can write 7,429. So ഇവിടെ അവസാനിപ്പിക്കുകയാണ് answer. Why? Because 23 is prime number. So our division is over. So we got the factors. So this number we can factorize as, now we are writing factor 3 for this answer. So 17 times 437. Again, these two we can write as 19 and 23. Factorize. This is the factor 3 of this. So finally we have to write 7,429 is equal to 17 into 19 into 23. This is the final answer. So what is asked? Write the express 7,429 as the product of prime numbers. We have written product of prime numbers. Let us see another problem in another video. Thanks for watching.